Today we're going to look at section 10.5, density and displacement. So if we're talking about displacement, we are going to be putting a solid into a liquid, and that should cause the liquid to rise, right? So displacement is going to be how much that liquid rises, and our displacement is going to relate directly to our volume. So how much the thing gets displaced by the solid, that's how big our volume is going to be, right? Because volume is how much area the shape takes up. So that's going to be what volume is. I'm going to work on calculating density. And density is the mass of the matter given by volume, right? So if we have mass over volume, that's what we're going to find density. If you've taken earth science, you should know how to do this and work with that from there. Down here we have some metals and some densities that go along with these. These are going to be important as we work through today's lesson and as we look at our homework, knowing what these densities are, whether we're trying to figure out what the metal is or how dense something is based off of that. Okay, so that is our density. Moving on into some example problems. Given some metal that has a mass of 377.02 grams, and it's been placed in a graduated cylinder, so just a cylinder, kind of sciencey there, filled with water. The water is at 10 centimeters when it is empty, and the cylinder has a radius of 3 centimeters. Once the metal has been placed into our cylinder, the water level is going to raise 1.5 centimeters. So what type of metal is in the cylinder and what's its volume? Well, to figure out what type of metal it is, we're going to use density. But to find density, we need mass and volume. We're given mass, and we can calculate volume. So given our picture here, we have a cylinder, and we put an object in there. Our object that we put in there looks like some shape like this. The original water level was at 10 centimeters. Then we placed the object inside, and the water level was raised 1.5 centimeters. So if we raised the water level 1.5 centimeters, that means that our height is now going to be 11.5, right? Because it went up 1.5 centimeters. Okay, great. What does that help us with? Well, the water level that raised is going to be our volume. So to calculate this volume, we are going to take the radius of this new cylinder that's formed right here in the green. So to find that, we need to figure out, well, it's a circle, so that is pi r squared, well, r is 3, and then times our height, which is going to be 1.5. So we take pi times r squared times 1.5, and we get an answer of 42.411. And for this, we're just going to go ahead and actually round to the nearest tenth spot. So 42.11 is what we're going to use. We've found the volume of our shape. So the volume is 42.41 centimeters cubed, right? Because that's how you measure volume. But we're looking for also what type of metal it is. To find the metal, we can use the density of the object. So if our mass is 377.02, we divide that by 42.41. That'll give us our density. And when we do that, our density comes out to be 8.89. We look back on our first page to figure out what type of metal that is, and it is nickel. So to figure out our density, we went ahead and found our volume, divided mass by volume there, and then we got our density, which tells us that it is nickel because we related to the closest one possible. Moving on to the next question, what is the mass of the block of the copper that is 2 by 2 by 4? Well, we draw on a quick block here so we get an idea of what we're talking about. It says that it's 2 by 2 by 4, so maybe we go 2 by 2 by 4. And in wants to know what the mass is. Well, we can figure out what the volume is of this. So that way we can use our density equals mass over volume. Our volume, it's a cube or a rectangular prism, so we'll do 2 times 2 times 4. So our volume will equal 16. Then where does that play in? Now we're going to look at the density of our copper, and the density of copper is 8.97. We do 8.97 equals mass over velocity, or volume right there. Volume is going to be 16, so we'll go ahead and put that in. Then we take both sides, multiply it by 16. Right, so that way those cancel, leaving our mass to be 143.52. And this is going to be in grams because that is how our volumes and densities are measured. Next problem, moving on, staying with this kind of idea here, we're going to have a rectangular container that is 4 centimeters by 3 centimeters and has water that is at 8 centimeters deep. We're going to place a rock inside of this rectangular prism here, a rectangular container, and the water level is going to rise to 10.14 centimeters, 10.4 centimeters. Find the volume of the rock. Well, we've got a container here, and we placed some rock in there. It was originally at 8 centimeters, and then it rose up to 10.4 centimeters, right? So we want to find the volume. Well, that's just going to be the volume of that rectangular box that's now formed by the green shape there. So we take the green, maybe draw another rectangular box. When we draw this box, we find that our base is still going to be the 3 times 4, right? Because that's the shape of our thing there. Then the water level, well, it raised from 8 to 10.4. So if I want to do some subtraction there, 10.4 minus 8, that should give me an answer of 2.4. So that means the height of my shape over here is going to be 2.4. We'll find the volume of a rectangular thing like that. I take 3 times 4 times 2.4. And when I do that, my volume comes out to be 28.8 centimeters cubed, right? Because it's a volume. So that would be the volume of my rock. Do I know what shape it is? No, but I know that it'll contain at least that much volume. All right, moving on to our last question. We've looked at how to find the volume of said rock or said shape placed in any cylinder. I've been able to calculate the density or use density to calculate some volume. This last one we're going to look at, and it says there's a lump of lithium that's handed to you. Find the metal's weight, where you find that the metal's weight is 172.34 grams. You place it in a non-reactive liquid, and that fills it to 8 centimeters square prism, right? If you put the lithium in the prism, how high should the liquid rise? So right now we have a square prism that looks like this, okay? The prism's like this. It's got an 8 by 8 by 8. Everything is 8, and it's filled completely full. Now we're going to place our lithium in there. We'll keep it consistent here. The lithium is going to be black. It's just black rod like this, okay? And we know its weight. How high is that going to raise the top of our box? So if we're looking at our box here, how high is it going to raise it in the green? So if we extend it up like this, how high will this green area be lifted up from there? Well, to figure this out, we probably need to find the volume of the lithium, right? So that way we can work with it there, because we want to know the volume that's been raised up, because that's what our green area is going to be. Well, to find the volume, we can use the density of lithium and our mass. We look at our density of lithium, and the density of lithium is going to be 0.54, and that'll equal our mass, which is 172.34, and that's all going to be over our volume. So working to find the volume here, we take the volume, multiply it to the other side, so that way we can get it out of the denominator. So then we have V.54 multiplied by it, right, equals 72.34. What I did up here was volumes. They cancel. Volume over there. All right, now I want to divide by 0.54, divide by 0.54. When I divide that, my volume comes out to be 319.5. Okay, so we've got our volume. Well, how does that help us? Well, the volume of this box now, we need to know what that originally was. So we go back to our red box over here to find the volume, the 8 times 8 times 8, which will give us an answer of 512. So our original volume was 512. When we added the lithium, we're adding a volume of 319.15. So when we add those together to figure out what our total volume should be, we get our answer for our new total volume should be 831.15. So that's our total volume when we add the lithium into the box. Well, how do we find the height of that? We know that to find the volume of any shape, we have the total volume, which we are going to label as 831.15. And then it's going to be the area of the base times the height. Well, the area of the base is a shape that is 8 times 8. And then we want to know the final height of this object over here, because we have the two bases, which are both 8. To find the final height, we need an h, because we don't know how high that is. We just have the volumes added together, which is this number here. So I can take 831.15 equal to 64, just multiplying the 8's together, times h. Then to find h, finally, I want to divide by 64. Divide by 64. And so when I divide this by 64, my height comes out to be 12.99 centimeters here. Pretty close to 15. I made 13. I maybe could have rounded it up. I didn't. I just kept it consistent with my rounding. So there's my height. So today we talked about using density and volume, moving them together. So being able to find the density given the mass and volume of a shape and determining what type of metal that was. We also talked about using mass and density, figure out the volume of a shape. And then we worked on this one using volumes and all that stuff together to find out how high the water would go. So here's an example of using density. Your homework is going to be on this page here. Good luck with this and have a great day.